Hello everyone, I'm Jayneel Parekh. I'm a third year undergraduate at IIT Bombay. So I'll be presenting the MLPBOON predicting media interestingness system. So before I start, I've seen sophisticated and really interesting systems, not in this task but other tasks too, and I'm really learning a lot from them. And these are like my first steps into research, so it kind of fulfills my purpose for this visit. So what I'll be presenting would be a simple system, and it's like a result of an exploration from whatever data that was given to us. So okay, so we have focused only on the image interestingness subtask, and no additional metadata or no additional data. So we did realize the intrinsic issue of subjectivity prior to starting the task, but still we had a mindset to maybe identify features which kind of quantify any common grounds on which humans classify interesting images. So this is what our approach is, to find right set of features, maybe focus more on the features, so that any simple classifier gives us good results. So yeah, this is our basic description. So we have a input data, we first normalize it, we apply PC on it, and then we use logistic regression as a classifier. We'll come to that, why each block is as it is, and then we classify the test examples. So yeah, so basically these are the three sets of features: gist, color histogram, and CNN features of FC7 and ProbList from AlexNet, with which we experimented. So we started with the first two, and it didn't kind of give us very positive results. So we then moved the ProbList, and it did show significant improvement. I mean, okay, so just let's get a step back. So how we experimented was that we use 4-fold or 5-fold cross-validation on the development set. So we use Weka and scikit-learn Python to implement as many classifiers as I could get hands-on, and we use these sets of features for experimenting. So the first two didn't kind of give good results. We moved to the prob layer. It gave much better results. Then we tried the FC7 layer, and the results improved even further, though not much significant in the prob layer, but still visible. So we kind of decided to stick with the FC7 layer, and now since they have 4096 dimensional feature vector, so it was like natural to apply PCA on it. So then we, because even while experimenting, we obviously use PCA for experimenting with the FC7 layer, and then came the classifier part. I mean, deciding the classifier. So again, all the classifiers, again the experimentation was the same. We use 4-fold or 5-fold cross-validation on the development set, and these were the classifiers that we used. So most of the classifiers, like, they didn't usually cross the map of 0.2 over the development set, but the logistic regression frequently crossed this value of 0.2. So we then stick with logistic regression. So yeah, here are the results. There are a couple of interesting things that we can note here. Okay, I'll just move back and forth. So one thing is that 400 features, they capture 95% variance of the data, and 780 features capture about 98%. So first I would like to point on these things. The results are very similar because the classifier is same, the features are same. I mean, this is what I believe, that in essence all the results are similar, and that's what points to the map that we are obtaining. I mean, I feel that these are close values, and I mean, I really can't explain, the things that differ for such variation, because I feel the essence is same in everything. And yeah, so this kind of points out that we have wasted some of our runs. I mean, we could have utilized it somewhere else. And yeah, some things like the penalty parameter, we can see that the number of features as they're increasing, it kind of reduces. So our basic approach was to first fix the number of features and then see the value of the penalty parameter that gives the best result on the development set. So yeah, and yeah, in conclusion, we can see that our system was pretty simple, and but still we obtained a reasonable map. And another thing that I'd like to point out is that the maximum value was actually just a fluke. I mean, you can see the maximum value is for 2016 features, which I just did because it was the year 2016. So I gave a thought on the first 4 runs, but the 5th one I just did. I don't know why. So yeah, for a future work, I mean, I think that the mid-level features, the face expression features, we were given the face detection and tracking features. I believe that if we could get the face the intensity of expression, that could be really helpful in this task. And if I would have got the time, I would have worked on it. So yeah, thank you.
Thank you.